Hello, welcome to Prajim Technologies. I am Venkat. This is part 50, Access Modifiers. In this session, we'll talk about internal and protected internal access modifiers. In the previous session, we learned about private, public, and protected access modifiers. And we know that a private member is accessible only within the containing class, whereas a public member is accessible anywhere. There are no restrictions whatsoever. And a protected member is available within the containing type and the types derived from the containing type. Okay, in this session, about internal access modifier and protected internal. Okay, a member with internal access modifier is basically available anywhere within the containing assembly. So to understand the internal access modifier, we need to understand the concept of assemblies. Now, in .NET, if you compile a project, an assembly is generated. And in .NET, basically the assemblies are of two types, executables and DLLs. Okay, usually a console application generates a .exe, Windows application generates a .exe, but whereas a web application, a class library generates a .dll. Okay, now if you look at this solution, it has got a console application. So when we build the solution, a DLL for this project will be generated. Now in this solution, we only have one project. So obviously one executable or one assembly will be generated. Since this is a console application, an executable will be generated. And if you want to look at that physical assembly, what you need to do is just right click on that, open folder when in Windows Explorer, bin directory, debug, and you see that we have introduction to C#. That's the same name as that of your project. Okay, so this assembly gets the name of its project, and since it's a console application, it will generate an exe and not a DLL. Okay, so this is your assembly. So what does this assembly contains? It contains the intermediate language of your project. So all your project classes, methods, structures, etc. compiled intermediate language is generated and it's packaged into this assembly which we have just seen. All right, now since we want to understand internal access modifier here, we need to have different assemblies so that we can define an internal member in one of the assemblies, try to access that from a different assembly and see if it's accessible or not. Okay, and to do that, we need to add more projects to this solution. So to add another project to this solution, just right click on the solution, add new project, and Visual C# as a programming language. I'm going to select class library, the project type, and let's call this assembly 1. So I'm giving my project assembly 1 as the name of my project. Click OK. So what is this going to do? It's going to generate another project. So if you look at the solution file, here you have two projects in the solution. One class library, one console application. Let's add another class library, and to do that, add new project. And I'm going to call this assembly 2. So assembly 2. And when I click OK, so another project is added. Now if I build the solution, basically all these three projects will be compiled, and for each project an assembly will be generated. So if I want to find the assembly of this project, just right click on that project, open folder in Windows Explorer, get into the bin directory, go into the debug directory, and you see that there is a DLL this time. Okay, so in .NET, assemblies are of two types, .dll or .exe. Now since we have understood the concept of assemblies here, okay, now if you look at this assembly 1, we have a file, a class file, class1.cs. Let's leave that name, but in reality we give it a meaningful name. Okay, for example, if I'm creating a customer class, I will name it after the class name, maybe customer.cs. Similarly, if I'm creating an employee class, employee.cs. Since this is just a simple example, I'm going to leave that as class1.cs. So class1.cs. Let's get rid of this unwanted using directories here. Let's make it the program as simple as possible. Okay, so if you look at that, we have namespace 1. I'm going to call this assembly 1 class 1. So this is class 1 that is present in this assembly. And in this class, I'm going to create an internal member. So internal, oops, not interface, internal integer, and let's call it ID, and let's initialize that to maybe 101. So we have this internal member here. Now, if it was public, then it's accessible anywhere. There are no restrictions. This is internal. Okay, it's available only to the classes that are within this assembly. So if you add another class, so look at this, to this project you can add another class if you want. Okay, and even to that class this member will be available. Okay, or what I can do, in the same file I can create another class, maybe public class, maybe let's call that as assembly1 class 2. And now within this class, let's say I have a method public void sample method, and if I create an instance of this class here, I should be able to access this member. So assembly1 class, maybe a1 is equal to new assembly class 1, and when I say a1 dot, I'm able to access that ID member. So if I simply say console.writeLine, it just writes that onto the console. And now when we build this, go to the build menu, build solution. We have an error here somewhere. What does it say? The namespace assembly1 already contains a definition for assembly1 class 1. Okay, let's call this class 2 because we already have class 1 here. Okay, so what we are doing here, assembly class A1 is equal to new assembly class 1. We created an instance and we are trying to access the ID property. So if I build this solution, it should build without any problem. Okay, since this is an internal member, I can access this within any class of this assembly1. But on the other hand, if I try to access this, look at this, I have another project. When I build this assembly2 project, we get another assembly. So from this assembly, if I try to access this internal member just like how we have done here, we will get a compiler error. Okay, so let's try to do that and see what happens. So in class 1, so this belongs to assembly2 project. So let's call this class as assembly2 class 1, so that we are clear on what class we are creating. So we have another class in assembly2. Now for this class, let's get rid of this unwanted code first. Okay, so if you look at this class is present in this assembly2 project. Now what we want to do, we want to create an instance of this class and then access the ID property in this assembly. But we know that the ID property is internal, which means this it's not property, it's a field. So this field is only accessible within the containing assembly, within this assembly. But we are trying to access it from another assembly, and internal access modifier will not allow us to do that. Okay, so let's see that. And before we do that, if we try to create an instance of this class, look at this, within the same assembly, I'm trying to create an instance of this class and it works fine. But on the other hand, if I try to create an instance of this class here, let's say public void, maybe we'll call this print method, and then this one I'm trying to look at that, a1 is equal to new. Basically you can see a red squiggly there, which is indicating I don't know about this type. So if I hover my mouse, look at that. The type or namespace assembly1 class 1 couldn't be found. Are you missing a using directory or an assembly reference? And that error message is very meaningful. So are you missing a using directory here or an assembly reference? Okay, now where is this class present? This class is present in assembly1 project, and we know that when we build this project, assembly1.dll is generated. Now we need to use the DLL in this project in order to be able to access this. Okay, just like how you're using console class. Look at this. For example, if I want to use the console class, I can say console class. But where is this console class coming from? It's coming from the system namespace. Now if you look at the references, you have the system assembly here, and within that system assembly we have the console class. That's why you are able to access that. But on the other hand, assembly1 class is available in this assembly1 project, or in this assembly1 assembly. Now you need to refer that assembly in your project to be able to access that class in the first place. And to do that, you need to set the reference. Okay, and to set the reference, just right click on the folder and say add reference. In the add reference dialog box on the projects tab, you look at that, you can see assembly1 project and introduction to C# project. But you don't see it here because you don't see assembly2 in this list. That's because you are adding reference to this project itself. So I select my assembly1 here, and the moment I do that, look at that, assembly1 assembly is added as a reference to this project. Now you don't have that error gone. You still have that error. So the type or namespace assembly1 class 1 couldn't be found. Are you missing a using directive or an assembly reference? We are not missing the assembly reference because we have already that. Then what else are we missing? We are missing the using directory. Just like if you want to access the console class, we have the system assembly here, but if I remove the using directory, can I access that? I can't. So it's the same case here. You need to use the using directive. So using, what is that? Assembly1. And the moment we do that, the error goes away. Okay, now let's go back to our discussion of access modifiers. So what are we doing here? I'm trying to create an instance of our assembly1 class, which is defined in another assembly. And this assembly1 class has got an internal member, and we want to be able to access this one. And let's try to do that and see what happens. Now when I try to do that, a1.id, look at that. First of all, the IntelliSense doesn't show up that, which means you're not allowed to access. And if you forcefully access that, maybe to initialize to 101. If I try to do that, and if we build, we will get compiler error. And that basically is telling us you're not allowed to access that. Why? Because that's an internal member, and if the member is internal, then it's accessible only within the assembly where it's defined. You're not allowed to access it outside of this assembly. But in spite of this being an internal member, we are trying to refer that in this assembly. So this assembly is different from this assembly, and internal members are accessible only within the containing assembly. Any code outside the containing assembly tries to access that, you will get a compiler error. That's what is internal. Okay, now what is protected internal? This is interesting. Protected internal is a protected and internal. Okay, now let's go back to the slides. We know that a protected member is accessible within the containing type and the containing type. And what does internal say? Internal members are available anywhere within the. So internal is a combination of protected and internal. So internal means it is available anywhere within the assembly. And if it is also decorated with protected access modifier, then it means that's accessible inside the assembly, but those classes outside the assembly should be deriving from the containing class, and the containing class can be either in the same assembly or in a different assembly. So if you look at protected internal, anywhere, so a protected internal member is accessible anywhere within the containing assembly and from within a derived class in any other assembly. So even classes within other assemblies also access this as long as they are derived from the containing class. Okay, so let's look at an example which hopefully will make it clear to you. Okay, now here this member ID is currently internal. Now let's do this. Let's mark this as protected. So if I mark it as protected internal, we know that this member is accessible anywhere within this assembly1 project in the solution. I mean, within this assembly1. That is done by internal. But since I also have protected here, which means any class which is deriving from this class also can access that, and that class can be in any other assembly. So now I have assembly to another assembly. In this assembly I have this class. What I'm going to do is I'm going to make it inherit from assembly1 class 1. Okay, now this class is inheriting from this class. So obviously this member is protected internal. So this member should also be available within this class, in spite of this class being present in another assembly. But then you can't access that on the instance of assembly1 class. The way to access that is you can simply say base.id 101. Or what you can do, you can actually create an instance of your own class, assembly2 class 1. Since this class is deriving from this one, from the principles of inheritance, whatever members you have derived here will be available to this class. So if I create maybe A2, and when we say A2 dot ID, you should be able to access that. All right. So, so the fact that you have marked it as protected internal makes it available within the containing assembly and to the classes, even if they're in some other assemblies, they can access it provided those classes inherit from the containing class. Okay, that's protected internal. Okay, so if you look at the definitions, it's pretty clear. A member with internal access modifier is available anywhere within the containing assembly, and it's a compile time error to access an internal member from outside of the containing assembly. Similarly, along the same lines, protected internal members can be accessed by any code in the assembly in which it is declared, or from within a derived class, even if that class is present in none another assembly. It's a combination of basically protected and internal, and if you have understood protected and internal access modifiers properly, it should be very easy to follow. Alright, on this slide you can find resources for ASP.NET and C# interview questions. That's it for today. Thank you for listening. Have a great day.